Welcome to Lecture Line. Here we have another equation. We're supposed to solve it. With other words, we're looking for the values for x that make the left side equal to the right side. Notice that there's two fractions, one on each side, and we want to get rid of the fractions. What we can do here is multiply both sides of the equation by the lowest common factor of both denominators. The lowest common factor would be the product of 2x and 3. So in other words, what we're going to do is we're going to multiply both sides of the equation by 3 times 2x and see what we get. So on the left side, we're going to write 3x plus 1 over 2x, and we're going to multiply that times 3 times 2x. And of course, when we do that to the left side, we have to do exactly the same to the right side. So this becomes 1/3, and we're going to multiply that as well by 3 and 2x. Of course, the reason why I wrote that instead of 6x, it makes it easier to see how this works. First of all, on the left side, we'll multiply this times this. Notice the 2x's will cancel out, and we're left with 3 times 3x plus 1. So this becomes 3 times 3x plus 1 on the left side equals, on the right side, the 3's cancel out, and we end up with 2x on the right side. Now, of course, the next step would be to get rid of the parentheses. So this becomes 9x plus 3 equals 2x. And now we want all the terms that have an x in them to the left side and all the numbers to the right side. Notice in this case, we're dealing with a linear equation, not a quadratic equation. So the method is to move all the x's to one side and all the numbers to the other side. So 9x minus 2x must equal -3. Notice when you move anything across the equal sign, the sign changes, in this case from a plus to minus and from a plus to minus. Now combining like terms, 9x minus 2x is 7x, and that equals a -3. And then dividing both sides by the coefficient in front of the variable, in this case the x, we end up with x is equal to -3 over 7. Now we need to make one more check. Notice that we had an x in the denominator here. If for some reason we came up with the solution that x had to equal 0, that would be a non-acceptable solution, because then when we plug it back in the original equation, we end up with a 0 in the denominator, which is undefined, and therefore that would not be a proper solution. But since it's not a 0, we can plug it in here, it's just fine. When we plug in x equals -3 over 7, on the left side, you can see that this would then equal the right side, and therefore that makes this the correct solution. And that's how it's done.